Hey folks, welcome back to Ed's Garage. Today I am embarking on a bit of a project. I have here a 2015 Chevy Spark EV battery. So this is basically it's a defective battery out of an old electric Spark. And as you know, I do like doing a lot of projects. So batteries are always at kind of a high demand. For instance, in the trailer here, I've got 3 kilowatts of batteries being powered by 500 watts of solar panels, and I've got a little scooter right here. It's an electric scooter, runs off of lithium or nickel metal hydride, lead acid batteries. Wow. So I want to do some conversions. I want to make some battery packs. This is basically, it's about 18, I think it was 18.4 kilowatt hours of battery. But there is a failed module inside here. So probably a failed cell within a failed module. But what I'd like to do is disassemble this battery, pull out those modules, obviously see if I can figure out which one is defective, and then kind of go from there. So this is what should be done with pre-owned batteries that are no longer being used in electric vehicles. Find a way to reuse them, recycle them, whatever. Now, obviously not everybody can do this. I am not really qualified to do this, but I do have a lot of experience in this area. I have the high voltage equipment necessary to disassemble this battery safely. But if you are just a DIYer, I'm just going to tell you, well, you know what? If you're anybody but a qualified technician, I'm going to say this once: do not attempt this at home. This is extremely high voltage, very, very dangerous, and shouldn't be attempted by just anyone. So I'm undertaking the risk. I know the risks, and I have the equipment necessary to do this safely. So first thing I got to do is basically pull the cover off. So let me show you a little bit around the battery here. The battery is actually held together in like a clamshell design. So there's a top and a bottom, and it's held together by a whole bunch of these little bolts here. I think there's probably about 50 of them around the outside. You can see on the front here is a little description on how to lift the battery if necessary. So it's got points that you can put hooks to basically lift the battery. Right here would normally be a 350 amp fuse. That has been removed. So there's no power going to the high voltage ports, which are on the end here. And that's essentially where we connect to the vehicle. Those two lines are the coolant lines. And then we have some ground straps down right over here. All of these big holes here, that's actually what's holding it to the underside of the vehicle. And on the back, there really isn't much to talk about. So what we're going to do, and then of course you have the warning here showing that it's a 400 volt system, high voltage, danger, danger. Don't open it, blah, blah, blah. So what we're going to do today is pull all these bolts off, crack this battery open, and have a look inside. And yeah, future videos will be about how I'm going to use those batteries. Let's get started. All right, so these are 8mm screws, or bolts rather. Show you what they look like here. Pretty small. Yeah, there's quite a few of them. So I'm going to count them, see how many we got here. Okay, there's 43, which is a weird number. However, I did break a couple. And look at this. Some of them, the core actually came out. They were so badly rusted, which is mildly worrying. So there's one on this side that I couldn't get out. It's so badly rusted that it's just stripped. So I'm going to have to maybe use a extractor or drill it out or something like that to get that one out. All right, I've got all the perimeter bolts out. Managed to get the other one out that I thought was rounded off. Managed to get it out with a regular socket. So now I need to pull off the little fuse holder here. Should be the only thing left. Yeah, there we go. Now I'm just going to wear the gloves as a precaution. So these are basically they're electrician, they're linesman gloves, and they're good for up to 12,000 volts of protection. Obviously you don't want to rely on these, but they should do the trick. So the reason I'm putting on the gloves already is because when I lift this off, I have to wrap my fingers underneath a little bit, and I don't want there to be any chance of my fingers touching anything they're not supposed to. So I want to make sure I'm good and planted, don't want to fall on this thing afterwards. This isn't very heavy, it's just made of like fiberglass or something. There we go. Came off quite easily actually. There we go. All right, 6 modules. Cool. Let me show you what we got here. You can see the negative terminal, positive terminal. Now, what I'm curious about is how these are actually connected up in series, because my next goal basically is to start disconnecting the lines to basically segment each one of these modules. So, of course, with all of these hooked up in series, they're making a total of 400 volts, but each one of these modules has the same amount of lithium cells in it. So each module is going to be about 66 and a bit volts. Each cell, of course, is going to be around 3 to 4 volts. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 cells. So fully charged, each cell would be 4.4 volts, which is pretty standard for a lithium-ion cell. So that's basically on the very, very high end though. So I doubt this pack ever actually is charged to a full 400 volts. It's probably more like 390 or something like that. So before I start disconnecting things, I'm going to get the gloves on and I'm going to start testing voltages of each one of the modules. I'm curious to know which one is the bad one. I can see there's a couple BMSs on the side here. That could be very handy actually. So very, very excited to see what sort of voltages I get out of these. All right, so before I start testing it, I'm just going to give you a quick overview of what I'm seeing here. So I assume that this is the contactor. I mean, it makes sense. It's the only large component in here aside from the battery modules themselves. So you could see the 2 main lines coming out. Those go to the car, so presumably one's positive, one's negative. Doesn't actually say which is which very easily. And then we got the main sort of high voltage lines going in here. I'm really excited here because this is a lot of material that I have I'm going to be able to use for all sorts of different projects. And then looking at the cooling inlet, this might be a little pump, so I could use that for something as well. This is pretty cool. I can see the fluid lines. Let's see here. So there's going to be a return and a pumped fluid. So this goes in, goes around here, and each one of these sort of parts where it goes down, it's going down to the looks like maybe the bottom of the battery packs. All right, let's start testing. All right, so we're going to put our multimeter on volts and of course DC. All right, so on this module we get, yep, makes sense. 56 volts. Yeah, these are all discharged, by the way. So, unfortunately, the previous owner of this vehicle, his battery was low, and it was when he went to charge it that it no longer wanted to charge. So, 56.2 volts, 56.3 volts. These should all be within around the same range. Oh, 56.1 volt. Okay. 56.4 volts. 56.3 volts. I can't see the multimeter anymore, so I'm going to move it. And 54.4. Okay, so this has got to be our failed module. That would make sense. All right. So now I'm going to actually check to see how this line works. So currently there is no max voltage going to the contactor. There's actually nothing going to the contactor. It's just dead. And that's probably because the fuse is removed. So I'm going to see where it goes to the fuses. It looks like it goes to the fuses right from the middle of the pack. So between this bank and this bank. And I suppose that makes sense, so cutting it off right in the middle. So yeah, let's follow the circuit. All right, so coming from the negative side of the contactor, goes into here, across, and then you can see this bar goes across to the negative side of this module, comes out of this side, of course, and goes around to this module, comes to here, boom, goes right into the fuse box. From the fuse box, goes to module number 4. Across to the positive side. The bus bar goes to this module, across the positive side, to this module, across to the positive side, and back to the contactors. Neat. Okay, so now it's just a matter of just disconnecting everything. So I am going to start, let me think here for a second, what would be the safest way to disconnect this? I think the safest way would probably be to disconnect right in the center of each bank. So I'm going to start, let me see here, I'm going to start with this one here, disconnect this, because then all we have is 2 banks connected, and then I'll disconnect the other side. So disconnecting this one basically removes the connection between these 2 modules, and then I'll disconnect that one. So I'm going to disconnect those 2 bolts and then 2 bolts on this side, and that should separate each module from the next. All right, so each one of the bus bar bolts is 10 millimeters. So I have my safety ratchet here. Go ahead and take those out. Now, one thing I want to be very, very careful of is to not drop any metal bits anywhere, not drop any metal tools anywhere. So this ratchet is protected at the moment. All right, let's get that disconnected and out of the way. Now I'm disconnecting the negative sides so that if there is any sort of grounding straps or anything anywhere, I don't mind the negative sides actually hitting the grounding straps. It actually doesn't matter because this is coming off the positive side of this battery module. So, but I don't know, I just feel better doing it that way. I'll disconnect the positive sides after I've disconnected the 2 negatives. Okay, so that should now completely separate these 3, but of course we still have this one. Well, actually this one's just going to the fuse, so this module is now completely disconnected. This one is also completely disconnected. Let's see here. Yeah, so this is actually a positive side from this battery. All right, so now that I've got those disconnected, I'm going to go ahead and do these ones next. All right, should be perfectly fine to now disconnect all of the other ones. So these are a lithium-ion polymer pack cell. Each one of the cells in there is a packet style cell with a polymer gel electrolyte. It's actually a pretty good technology. Depending on who you ask. Another thing to keep in mind when disassembling a battery like this is to never put the tool down anywhere in the pack. Okay, there we go. That center bus bar completely disconnected. All right, I've successfully, completely de-dangerfied this battery. So each one of the modules now is completely separated from the next. So I'm going to go ahead and see what is involved in taking out one of the modules. It looks like it's held on by, it looks like maybe 6 bolts along the bottom. Tough to see exactly here, but I need to get some more of this wiring and piping out of the way in order to pull some of these modules out. So a 66 volt module, when fully charged, 56 when discharged by the looks of it, around there anyway. What's that going to be useful for? Well, you can run inverters off of these and bump the voltage up to 110 volts AC in order to use that for regular household appliance type stuff. My plan is to actually take a couple of these modules and use them for battery backup for the house, so that if the power goes out, I can run the house off of maybe 3 of these. And then I won't even need an inverter. If I run 2 of these, maybe actually I'll use 4, because then I can run 2 in series and then the 2 packs in parallel. And then the inverter basically won't need to do much. It'll just need to convert to AC. So that's pretty much what your home voltage is anyway, 120 volts roughly. So let's see what goes on here. I'm going to go ahead and stop recording for a bit while I kind of pull away some of this stuff. All right, just want to show you where I'm at here. Just in the process of taking this one module out, and basically it was held down by 2 metal brackets, one on either side. So the one metal bracket in between the 2 modules holds 2 modules in place, and then of course that one holds the outside of this one. So what I'm working on right now is just disconnecting the coolant lines, and then I should be able to pull it out. I've got the coolant lines disconnected. There is coolant in there, so I need to make sure to keep the battery upright because I don't want to have that coolant dripping out. I got a couple of little small connectors that need to be disconnected. Just trying to figure out how those work. Oh, there we go. You can see that on camera there, yep. And it looks like just a clip. So this is probably temperature sensor, would be my guess. And then we have the BMS line right here. So this needs to be disconnected as well somehow. Let's see how that's connected there. Oh, there we go. So I guess I just had to pull on it. Interesting. I'll probably pull this cap off before too long here to get a look underneath. But that is it. That battery is loose. I don't think anything else is holding it in place. So let's pull that thing out. Okay. Now, of course, these batteries are liquid cooled and they still contain some fluid, so I need to pour that out. It's pretty heavy though. I'd say this weighs easily as much as a typical car battery. But just keep in mind it's significantly more dense. I need to make sure to dispose of this properly. Okay. All right. Time to measure this thing, see how much it weighs. All right, I took the cover off to expose all the tops of the individual cells, so now I'm going to be able to actually measure these individual cells and see how they stack up. There is indeed 15 of them, so they're all going to be discharged right now, but I want to see if they're balanced within the cells, within the back here. So I'm going to check to see the overall weight. Guys, this is 3 kilowatt hours of battery, which is just awesome. So this is going to make a really, really fun project pack here. And the weight, we have about 54 pounds. So 54 pounds, 3 kilowatt hours, probably a little bit less than that now just due to degradation. The overall pack degradation was about 20% before it failed. So I imagine this is probably close to that as well. We won't know until we do a full charge and slow discharge. All right, let's do a quick test on each individual cell and see how well these cells are balanced. So for cell voltage here, I'm not even sure. Oh, it's going to be back and forth, of course. Voltage. 3.54. 3.51. Wow, already unbalanced. 3.51. 3.52. 3.51. 3.52. 3.49. Wow. 3.5. 3.51. 3.52. 3.51. 3.51. 5.1. 5.1. 5.0. And 5.2. So that's interesting. So the cell voltages should all be within about 0.02 volts. We have a discrepancy. I think the lowest one was 3.49, right up to 3.53, I think, or 5.4 might have been the highest. So I think it's 0.05 volts separated, but that's okay. I mean, that just indicates that this needs to be charged. So, because yeah, the current pack voltage, this pack voltage is 56.3 volts. And by the way, guys, yeah, nothing to it. I can hold this, no problem. So 56.3 volts. These are individuals. There's 15 here. If they're at 4.2 volts each, then that gives us a pack voltage. What's the math there? I think it was around 62 volts or something like that. So at 66 volts, each one would have to be 4.4 volts. That's a little bit high for these. Obviously, we don't want to charge them up to their absolute max. So what I'm going to do is I'm going to get a charger that's capable of charging this many, or this layout of battery, and then of course it'll be able to properly balance them as well. Now that I've kept this plugged, I'm going to see if I can find the proper connector for this. I may just use the connector that came off the pack, plug it into here, and then find a proper BMS to charge this up. I don't need to cool this system, so I'll probably just pull off these extra little bits of hoses and stuff and then clean this up, put it in a nice box, and then I'll have a really nice 3 kilowatt battery to use for whatever. And if I have two of these together, then that'll be awesome. 6 kilowatt hours of battery that I can use for the house backup or whatever, or for my trailer. This will be a very, very handy thing to have. If I put this in my camping truck, I can use it to power an induction stove as well when I'm camping, which is awesome. Okay, well, testing out the voltages in that other pack got me curious. Because we know that this is the bad pack, I am curious to know if there is one cell in particular here putting out less power than the others. So I'm going to pull this one apart and have a quick look. This is actually the battery that the BMS is attached to, or well, it's attached to all the batteries in the pack, but it's the one where it's hanging off the side here. But let's check out the cell voltages here and see which one's bad. Because I mean, ultimately speaking, if you have an EV with a failed pack, chances are it's only one of these cells that's bad. So let's have a quick look. All right, we have 3 volts there. That is not much. 3.07. 3.41. 3.39. 3.38. 3.44. 3.38. 3.45. 3.4. 3.4. 3.42. 3.44. 3.41. 3.41. 3.44. 3.45. 3.41. Okay, so this one all the way on the end here, 3.0. So this cell on the far side is the bad cell. So this one single cell in this module, in this pack, is the reason that this entire pack needed to be replaced, because there isn't anywhere locally that will do a repair on a battery pack like this for some silly reason. I've been at this for maybe an hour, and I already had this entire module removed. I could have pulled out that module in the same amount of time, and then replacing that individual pack, I'm going to show you just how easy it is. Check this out. So these bolts right here, they go all the way through, and they hold this entire pack together. They squeeze it all together. So all I needed to do, or all anyone needs to do, is just pull those bolts out, disassemble this pack a bit, take that cell, pull it out, put another cell in there, balance it, put it back in here, put the whole thing back together. I think a professional, because remember, I've never done this before. This is the first time I've ever done this. And I got down to that cell pretty quickly. Now, a professional company could probably disassemble, replace that battery pack, or hell, replace that module if they don't want to disassemble the individual module. Replace the module, put it all back together in, 3-4 hours tops. That's, call it $800 labor, and an individual module, maybe a couple $100 for a used one, or even $1,000 for a brand new one. For $2,000, this pack could have been repaired, but instead, for some silly reason, the previous owner's extended warranty company and the dealership and the manufacturer all kind of, worked together, not together, rather, to require this whole pack be replaced. That is the ridiculousness of EV battery replacements currently. So hopefully we'll get to a point one day where this sort of thing is just not necessary. I mean, it works out for me. It's a win for me because I get to play around with this battery pack now and repurpose it for other things. But I mean, for the owner of the vehicle that this came out of, it's kind of silly. So thankfully, we were able to get him a new battery pack, or at least a replacement battery pack, a used one, and we managed to make it work within the warranty stipulations. So he had an extended warranty that would only cover up to the value of his vehicle, and unfortunately a new battery would have been twice the value of his vehicle. So we got a used battery pack for about $5,000, slapped it into his vehicle, and then with all said and done, it was just within the total that we could cover under extended warranty, which was awesome. So great for the previous owner, but it was a long, arduous, process of something like 6 months to get this done, and it took some out of the box thinking in order to get this done for him under his extended warranty coverage. But none of this was necessary if there was just a local company that would be willing to repair a battery cell like that, or if manufacturer actually taught their dealers how to do this. It's really not that difficult. 1 hour and I had that cell out, or that module out. Anyway, back to it. Not sure if it means anything. I got this failed module removed, but check out the color of the two modules that are in there. And now, look at the color of this one. That is quite a bit darker. So I'm guessing this one just overheated one too many times. Figured I'd do a quick bit to show you the contactor layout here as well. So I got two big ass contactors here and several smaller relays by the looks of it here, but they're all going to be usable for something in the future, so that's kind of fun. There is temperature sensors absolutely everywhere. Those are just wiring. But yeah, it's good to see that there's a heck of a lot of redundancy here. There's even an ammeter right here. That's pretty cool. So I'll be able to possibly use that for something, or maybe just sell it. A 600 volt fast acting fuse. Okay, so I've completely broken down the battery into its core components. It's completely disassembled. Check this out. We have the very bottom of the battery here. So I'm going to find some way to recycle this properly. You can see we've got some plastic tubing down at the bottom there. I can't really think of any good use or good reason to keep that. So that'll get recycled. Everything else has been removed pretty much completely. There's a couple of connectors at the top, and there's a little pipe there, temperature sensor mount. So I can't stress this enough, guys. This battery is still very, very, very usable. Social media, the market, the news, the media, whatever, would have you to believe that these batteries are completely useless after they need to be replaced, and that couldn't be further from the truth. So I'm doing this to basically demonstrate the usefulness of old EV batteries. Now, you've probably seen other videos that are similar, talking about, you know, what can be used, what can be done with used batteries. But I want to just go over some things here. I got this battery for free. Now, ordinarily, this entire pack would go through a shredder and get completely destroyed. And then the small components, the small little bits that are shredded off of it would be used for future battery production, which is fine. But there's a better way, and that is to utilize the good components first. So here's what we got. So I've also got a fifth one of these inside, but these four plus the one that I have inside are still perfectly functional modules. This cell, probably not so much. You can see it's darker than the other ones. You know, right from here, you can very easily tell. So this one just didn't get a whole heck of a lot of cooling. Not sure why, but maybe because it was the last battery in the pack module number 6. So while all the other ones have that nice light color, that's the only dark one. But that cell still isn't completely useless. So what I figure, I'm going to break down the totals here for you. Those battery modules there, I'm going to put a value of about $500 each on those modules. And the reason for that is because they're each rated for 3 kilowatt hours. Now, I'm not going to give me 3 kilowatt hours, probably more like 2.5 at best. So, and we'll test that because I actually have a battery tester that I can use to figure out the actual kilowatt rating that they're currently good for. So, with 5 known good modules and 1 bad one, 5 times 500, I mean, that's already $2,500 worth of batteries. And then that bad one, I don't know, we'll call it $100. So maybe $2,600. But check out this other stuff that I got from this battery. Now, total it up with me. So we're at $2,600. Got a little bit of metal here. I'm not going to put a value on that. This is the seal that was on that battery. I don't know what I can use this for, but it's a nice silicone seal, so I'm going to keep that. Got a couple of handy little clips out of there. A very heavy duty resistor. This I found online for about 30 bucks. So I'm going to call it $2,630. This fuse also worth about 20 bucks. So that's $2,650. And in the holder that it comes in, which is nice. All these nuts and bolts, which again, I won't place a value on. So $2,650 so far. Now these are BMSs. This, I'm not sure what the difference is. When I looked up the part numbers, they were both BMSs. This one was selling for about $300. This one was selling for about $190. So that's $2,650. So $2,950 plus 90. So $3,000. So about $3,100 now. Now these are contactors. These are about $130 each. So together, that's $260 worth of contactors there. So now we're at, what are we, 31, 32, 33.60. This thing I haven't been able to identify yet. I did a search for all the numbers on here, and it didn't seem to come up with anything. It has a high voltage positive output, high voltage negative output, and an out. I don't know what that is exactly. I think this might be what controls this right here, which is the fluid heater. So this is a DC current fluid heater. But yeah, I'll get to that in a second. These ones here, these are relays. They're about $30 each. So 30, 60, 90, 120. So I don't even remember the number we were at again, but feel free to add it up. This little guy is a $30 current meter. And then we have a temperature sensor here. It's probably worth, I don't know, 10 bucks. I'm not going to put a value on this stuff because I'm going to use this stuff for sure. So probably when I'm putting my battery pack together, because I'm going to have probably a couple of these hooked up in series so that I can convert to 110 volts, 120 volts very easily and maybe run the house off of that as a backup. So these will come in handy for that. These are basically just the bus bars and the wiring connecting all those things together. So I would say that, very, very handily, I've got over $3,000 worth of stuff. And all I did was basically save this battery from a recycling plant, or worse yet, a landfill. All of this stuff is still functional. The contactors, the relays, they're all in perfect condition. The inside of that battery is so well kept, so well sealed that there's no reason any of this stuff should have any issues at all. I mean, these contactors on the inside, they'll probably have a little bit of wear, as will the relays, but, not much. The battery heater, that's perfectly good. I have no idea what I can use that for. I might just resell it, but I might use it for some sort of project in the future as well. As for these BMSs, again, I don't think I can use them, so I'll probably sell those online on eBay or something like that. But yeah, there you have it. So lots of very, very valuable components. So first project will probably be to put together a nice battery pack, just something with like an inverter built into it, a bunch of USB ports, something that I can take along as kind of like an extra jerry can or something like that if I need to go on a longer trip with my car and I'm worried about, you know, needing to stop somewhere. This will give me a few kilometers anyway. So if I come up a little bit short, then something like this will be handy for that. So lots of different possibilities anyway, but this should be a lot of fun to figure out what I can do with this pack. Anyway, thanks so much for watching, guys. If you enjoyed this video, if you want to see future videos related to this EV battery pack disassembly, by all means, don't forget to hit like and subscribe. And until next time, have a great day.